Yeah, yeah, I'm Dr. Uttam Deshpande, Associate Professor of Department of EC. So I will be handling this subject called as Embedded Systems Design with Arduino. The subject code is 21EC554. So basically, this is a subject where we are basically going to design an embedded system with the help of a controller, okay, called as a Arduino. And this is the actual syllabus content which we will be covering. So here the to learn microcontroller or to learn Arduino, if you know basics of C, I think that would be sufficient because we would be doing programming on open source IDE, which is provided by the Arduino. That is called as Arduino IDE. So where we will be initially first learning what is basically an embedded system. To do that, okay, we should first know what is a microcontroller, okay, what is a general purpose computer system, and then we'll be trying to make some comparisons. Once we understand the concept of embedded system, what is embedded system, what is a microprocessor, what is a microcontroller, okay, and once we know how the computer system works, so we would be trying to make some study where we try to learn how the washing machine or a controller or a micro oven, such type of embedded applications are developed using the computer system. Next, we start with the Arduino, real Arduino. We first try to learn the what you can say the architecture of Arduino, overall functional block diagrams, different ports. Once we are well versed with the hardware, then we should be able to start with the programming part. So we use Arduino IDE, and then we'll be using a tool called a Sketch, on which we'll be writing our Arduino program and we'll be trying to run and execute our program. So once we do some basic programming, like we try to run all the possible control statements and different statements to control the flow of the execution. Then we will be starting with the interfacing of the Arduino with the other sensors. So generally, why we are trying to talk about the embedded system is like we try to design a system and then we try to understand the system. Once we know the system, so obviously embedded system. I'll come down to what is that embedded system in a short while. So once the embedded system is ready, or once we learn the embedded system, so our job is to interface different sensors and then try to build some applications. So generally, we start with simple sensors, like we try to interface LED switches, keypads, temperature sensor, LM35, and then different motor controllers and all the relevant circuits that are required, because we need to learn the datasheet of these sensors and then we should also understand how to interface with the Arduino. So that we would be doing. So up till this part, the interfacing and working with Arduino will be very, very simple. Then we try to make it slightly complex and try to interface some complex sensors. So we talk about the robots because ultimately, once we say that the embedded system is developed, so the system can be used for several applications. So one of such application could be a robot. So we try to learn the robot and also we try to see how we can build the robot, or what could be the possible solution, okay, to build the robot using the Arduino. And connecting with the robot, we also will try to see the all the possible sensors like touch sensor, tactile sensors, proximity, range sensors, vision sensor, so that we build the bots and the bot should be able to navigate automatically. So this is the ultimate requirement at the end. Okay. So what we'll be doing is the overall structure of the syllabus I have explained you. So we start with the basic embedded system, understand the embedded system, then we learn the architecture of Arduino, do some simple programs, okay. Then we learn some interfacing using simple LED and keypads and the temperature sensors and so on and so forth. After that, once we get some confidence how to interface the sensors, then what we do is we try to build the bots. So first we understand the bots, how it works, and what are the different sensors that are required. Once we gather this requirement, and we will be interfacing these sensors with Arduino to build a slightly complex application like bots. So this is, I think, any student, okay, who is working on a computer system should know what are the different parts of the computer system. So this is how the computer system would look like. So we would be talking about what is RAM, ROM, okay, the IO devices, what is CPU, what is address bus, data bus, and control bus. What are these buses and what are the roles of these buses in controlling the application, controlling the data. Okay, then we talk about what is a microcontroller, because microcontroller is said to be heart of the embedded system. So embedded system is nothing but it is basically you try to sandwich both your hardware and software together with a piece of hardware. So the hardware basically comprises of a CPU containing some RAM, ROM, IO ports, timers, and some communication ports. And after we learn microcontroller, we also would be trying to make the comparison between microcontroller and a microprocessor. What are the differences? Because once we understand the embedded system thoroughly, then only we can talk about the application. Then what we would do is we would go through the Atmega microcontroller architecture and try to understand, because Arduino is a microcontroller which is having a 8-bit controller in it, and there are so many input output ports. So it's having a inbuilt RAM, it's having inbuilt ROM. So how much RAM, ROM, how to access this. One advantage of working with Arduino is you not have to get into more depth about the hardware. You should only be aware about the hardware. This is just for the knowledge sake. And once we understand the architecture of the Arduino, we should also be able to interface different sensors with it. So without getting much depth into the architecture of hardware, I'll be giving the overview of the hardware and how to interface with the help of IO ports. Because when we are trying to interface the sensors, it is required that we should have the knowledge about the ports, which are the analog ports, which are the digital ports. Okay, so analog ports, we should be able to interface all the analog sensors. Digital ports, we should be able to interface any digital sensor with Arduino using these ports. So there are input ports, okay, there are output ports. So all these ports we should try to understand first. So this is the basic what is required. As I've told, I'll be using a Arduino IDE called as Sketch. We will be using this particular tool. This is open source available, where we will be able to like write our program, okay, compile and build, check for errors, and finally once the program is up, what we'll be doing is we'll be dumping this particular piece of code onto the Arduino hardware, and then we'll be checking the output. So we'll be initially starting with, as I've told, simple sensors like your LED, LDR, or temperature sensor, something like that. Once we get the confidence of how to interface the sensors, so I'll be covering both analog sensors as well as digital sensors initially. Once we do that, okay, then we would be interfacing some slightly complex sensors and actuators. Okay, so these sensor actuators basically will help us or give us some confidence to get a deeper knowledge about working with sensors and embedded system or within embedded system using a Arduino. Once we do that, what we'll be doing is we'll be building bots. Okay, we'll be interfacing motors, we'll be interfacing ultrasonic sensors, okay, your camera sensors, all these sensors which are required for the bots so that we can make it functional. So we'll be doing this application at the end. So once we do this, so we would have built a bot which is an embedded application using the Arduino. So this is the overall flow of this particular course. So this is going to be a very, very interesting course, especially people who have not worked on Arduino, especially people from non-circuit branches. This is going to be a very, very helpful course, because you can once we can build a bot, small bot, you can build any complex application using the Arduino. So that is the amount of confidence that you're going to gain out of this subject. Okay, so this is going to be a lot of, so it's going to be like blended. So even though the course delivery is going to be 3 I think the theory will be covered as well as we'll be doing hands-on experiments along with this. So this is the preliminary requirement. So this I think what we would be doing. So also finally we can also do a lot of simulations. If you feel that okay, we would like for example some experiments probably it's not possible to do, what we can do is we can do a lot of simulations. So I'll be giving a lot of assignments and I'll be asking you to simulate the circuit, simulate the application, and we should be able to see whether it is functionally working or no. So once we do that, once we get a confidence working with this particular tool, then we can start with the hardware. So this is going to be the flow. This is going to be a very interesting course. So this is about developing an embedded application using Arduino.
Hello. So today I will be giving a demo on open elective, that is product design and rapid prototyping. So if you look at the picture here, you can see various products like car, refrigerator, motorcycle, etc. So each of this product, if an industry wants to develop, first they have to do a product design of the product. Then they have to develop a prototype, one or two prototype. Then if feasibility is there with a profit, then they can go for the manufacturing. So for in this subject, we are going to deal with product design as well as rapid prototyping, which is prototyping a few number the product that has been developed, and then after that releasing it to the market for its experience, then actual manufacturing. Now if you look at the syllabus here, you have 3 hours of teaching in this, 3 hours of teaching per week, a credit of 3. Okay, then the various course learning objectives of this are to understand the basic product development, to explain how to identify customer needs and product specifications, to explain how to select concept and testing. So the first 3 course learning objectives are related to product design, and the last 2 course learning objectives are with respect to the rapid prototyping. So this subject is mainly divided into 2 parts, that is product design and rapid prototyping. So there is no such a prerequisite for this subject. You should know the general definition of what is meant by a product, that's all. Now in unit 1 and unit 2 and also in unit 3, so we are going to learn with respect to the product development. So in unit 1 you have an introduction. So each unit is of 8 hours. In unit 1 you have an introduction to the subject, then a development process and organization, and a product planning, these 3 subunits. So unit 2, identifying the customer needs and finding out the product specifications, concept generation for a product. So that is there in unit 2. In unit 3 you have a concept selection for the product, concept testing, and finally after all that we arrive at a product architecture. So all these 3 units which are of 8 hours each is with respect to the product design. Then the last 2 units, unit number 4 and unit number 5, are with respect to rapid prototyping. So unit 4 and unit 5 is also of 8 hours each. So in unit 4 we are going to deal with what is meant by additive manufacturing. We are going to study in detail what is additive manufacturing, then classification of the additive manufacturing processes. So that we are going to study in unit number 4, and in unit number 5 also it is related to the rapid prototyping or additive manufacturing, and what are the applications of additive manufacturing, limitations, advantages, and so on. So this subject mainly divides it into 3 units and 2 units, 3 units for product design and 2 units for rapid prototyping. This is entirely a theoretical subject, but in case of in unit 1 to unit 2 and unit 3, we have some case studies with respect to the product design, so that we can go up to level 3 in the Bloom's taxonomy. Otherwise you will have the questions up to unit 2, but if including for unit 1, 2 and 3, we can go for L3, looms level. So unit 4 and unit 5 is L2 level, and you have a straightforward questions. The entire syllabus is of theoretical type and a case studies, few case studies. Textbooks for this subject, the first textbook is Product Design and Development by Carl Ulrich. This one, the first textbook. The second textbook is Additive Manufacturing by Ian Gibson. So that is this one, Ian Gibson. So this is the additive manufacturing book, which is for unit 4 and 5. This book is for unit 1, 2 and unit 3. One reference book, Product Design and Manufacturing, A.C. Chitale and R.C. Gupta. So this book, Product Design and Manufacturing. So all these books are available in the main library, and also soft copies of these books are also available in the websites. 2 e-resources, that is NPTEL links with respect to product design as well as with respect to additive manufacturing technologies can also be studied. So 4 books that you see are available in the library as well as with the soft copies. So this is with respect to this subject, product design and rapid prototyping, and this is a 100% theoretical subject. You can reach up to L3 Bloom's level taxonomy using this subject. Thank you.
Welcome to all. So this is a brief introduction to the open elective course, Statistical Design and DOE. DOE stands for Design of Experiments. This is a 3-hour, 3-credit course, and the whole subject is centered around the principles of statistics. Everything is around statistics. The main theme of the subject is application of statistics for improvement of quality and process. So the quality aspects of any product or a process are analyzed, and decisions are taken to improve the process and product quality by taking certain steps. So this whole thing is a very, very involved subject, and the syllabus has been quite a moderate one with enough of mathematics. So unit 1, to begin with, the unit 1, okay, and there is a prerequisite of basic knowledge of statistics. So one is supposed to know mean, median, and all those measures of central tendency and measures of dispersion. Okay. So about the syllabus, if you look at it, unit 1 is beginning with the basic statistical concept. So a brief historical statistical design is what is an interesting beginning part, which reveals how developments have taken place, leading to application of statistics in improving product and process quality. And then in the same unit, we have the measures of central tendency such as mean, median, and mode, and measures of variability or measures of dispersion, namely variance and standard deviation. Then introduction to experimentation is another part of unit 1. So where how the experimentation is done, usually it is discussed, and different methods of conducting experiments are discussed, and applications and basic principles, guidelines for experiments are discussed in this. And okay, it's about unit 1, and unit 2 is a testing of hypothesis, and type 1 and type 2 errors. And about experimentation, the simplest of the experiments is a 2-level experiment. So the basic definitions and principles, advantages of what is called a factorial design. So factorial design is a very elaborate method of experimentation involving all the possible combinations while conducting the experiments. And factors and levels are the terms which need more discussion, which probably would be understood much later. And this is about unit 2. And unit 3 is centered around what is called the Taguchi's principles, okay, or the Taguchi's orthogonal arrays. Genichi Taguchi was a Japanese mathematician and manager who did lot of work and contributed enormously in finding what are called efficient experimentation methods, and developed what are called OAs or orthogonal arrays. And the advantage of this method is that the number of experimentations required are quite less. So in lesser time, with lesser effort and lesser expenses, results can be obtained. So this is about unit 3. And also there is what's called signal to noise ratio, S to N ratio. And unit 4 is analysis and interpretation of the results of experiments. So after the experiments are conducted, it needs to be the results need to be analyzed and presented in a form so that decisions can be taken to enhance the process quality or product quality. So this is the last phase of the experimentation or DOE process, the analysis phase. So in the analysis, for analysis, we use softwares actually. Okay, manually it is not quite feasible and possible. So what is called ANOVA or analysis of variance is what is discussed in this chapter. And actually softwares we would like to demonstrate, though it is not there in the syllabus. And unit 5 is what is called the experiment to confirm the whole process of DOE. The confirmation experiment is conducted in a particular way. It is a mandatory step in DOE process. And also in the last unit, some interesting case studies are included. And this is about the syllabus. And we can go up to level 3 or 4, maximum 4 in 1 or 2 units. And about the books, we have the Taguchi Techniques for Quality Engineering, authored by Philip J. Ross, and Quality Engineering Using Robust Design, authored by M.S. Phadke. And there are reference books authored by Montgomery, Douglas Montgomery, and the book title is Design and Analysis of Experiments. And some e-resources are there, which can be discussed later. So about the CIE, Continuous Internal Evaluation, it consists of 2 internal assessment tests of 25 marks each, which amounts to 50 marks, and 4 quizzes of 5 marks each, which makes it 20 marks, and course project and assignments, activities, outcome-based activities for 20 marks, and a seminar of 10 marks, that makes it 100. And minimum of 40 marks are required out of 100 to be eligible for ACE, semester end exam. And the semester end exam is of 3-hour duration for 100 marks. And Other details are there in the syllabus. So again, the new question paper pattern is applicable, having parts A, B, C. Okay, part A consists of 7 questions of 6 marks and so on. Part B of 10 marks and part C of 20 marks. So it is about the syllabus for the subject design of experiments mainly, and yeah, statistical design and DOE. Thank you.
Good afternoon, everyone. Myself Anupama Kallod, Faculty Mechanical. I'm introducing today the Industrial Engineering Productivity Management course. So as you know, 21 ME 5512, it's an open elective with 300 as LTP and credits 3 and total content, contact hours is 40 and 5 flipped classes content. SWE 100 marks and CIE 100 marks. As all of you know, every industry, whether it is a software industry or whether it is a service industry or whether it is a manufacturing industry, everybody is, or any business you can take, everyone is striving for increasing their product demand or increasing, everyone wanted to increase their profit. Nowadays, the word profit is replaced by the word called productivity. So what is productivity then? Productivity is the ratio of number of products manufactured in a given period of time or the service rendered to the customer divided by the resources that are available. So what are the resources that are available in any industry? So we write them as 4 M's. So what are those 4 M's? M, money, material, machines and manpower. Or you can say physical resources and the human resource. Together, they, in the combination of both, they manufacture products or they provide the service to the customers and get the profit out of it. So to make it more effective, more efficient, or to make more profit, the productivity of the organization need to be improved or increased. It can be applied to any type of business or any industry or even at home. We can apply the tools and techniques which are available, which you are going to learn in this, so that you can make yourself as an individual more productive, more efficient, okay, and you can make the things better. You can earn more profit. You can say if at all you are going for business or if at all you are going for some industry, you are going to make more profit or more efficient work, or you can finish the work in a less time with less resources. This is what is the concept. So industrial engineering is the concept wherein we are using number of tools which are available to improve the productivity of the organization or to manage the productivity of the organization. This is what it is. That's why the combination industrial engineering and productivity management. So in the first unit, you are going to learn the content of unit productivity. So what is productivity? What is the concept of productivity? What is the ways to calculate the productivity? All those things. Some numericals, simple numericals are also there in first unit. And different techniques, improvement techniques, productivity improvement techniques, we are going to learn in the first unit. Second unit, you are going to learn about what is work study. Work study is under this work study umbrella, we can put this or the combination of method study as well as work measurement. Together, we call it as work study. So what is work study then? It is nothing but study of work. Making whatever work we are doing more efficient, more effective, which will take less time, which will by doing that the worker will incur less fatigue and he will be he can finish it in less time, okay, with a more efficiency or with more output. That itself is work study, or work study techniques will be used for improving the efficiency of the either worker or the workplace or the industry or the business, whatever it is. So here in the second unit, you are going to learn the objectives, definition, scope, human factor, which is important. So two factors we identify. One is physical in any industry, whether it is a software industry or whether it is a hardware industry or mechanical or service industry. We are observing two aspects. One is human factor, another one is physical factors or physical resources. Physical resources, the machineries or the building, the land, material, all those things. And who is using it? The human resource. So both, the combination of these two should be such that we can make the productivity improvement in the organization. So to do that, we need to learn what are the techniques available, what are the tools that are available, how to use them, how to apply, so that we can make the work better. So that you are going to learn in unit 2. So in that, wages and incentives, how the wages and incentives are to be calculated, this, that and all that you are going to learn. What are the different type of or job analysis, how to do the job evaluation, job rotation, job description, how to write the job description. So what type of machineries are required to do the job, or what type of manpower is required, what should be the qualification, specification or experience. All those things you are going to learn in second unit. Then third unit is introduction to method study. So the core. So what is method study then? It is a part of work study only. That is the first step always in work study. So method study, you are studying the method of doing the job, or procedural steps. You are understanding existing procedure will be there in every industry. Unless it is a totally new product, the procedural steps are there to complete the product or to manufacture the product or to provide the service. One set of procedural steps are there. So you are going to understand those steps, you are going to observe that, and you are going to find out which are non-essential, non-productive, unnecessary elements are there. Remove them and make it, and then again you make the chart so that you can remove all the unnecessary elements, and you are having only productive elements which will complete the job without any hassles. So if you do that, the time required will be less, the fatigue incurred will be less, more efficient, more effective it will be. In turn, you can say that it is more productive work. So that how the method you are going to learn, you are going to observe, you are going to record, and you are going to analyze, and you are going to develop the best method of doing the job by eliminating the unnecessary elements. That you are going to learn in unit 3 with all these outline process chart, flow process chart. These are nothing but the tools which we are using to improve the productivity, to study the job or to record the job and to remove the unnecessary elements from the process and develop the best method, and then write it again and make it a habit, so that we can use the new method of doing the job which consume less resources, and we can complete it in a minimum time. Then fourth one is micro motion analysis. Once you finish the method study and some of the the jobs which consists of very smaller time, that is you can say that it may take 5 minutes to complete, or assembly type of operations, or some operations are take very less time. So it is very difficult to use all these charts and observe and write down and all those things. There we are using cameras, and we are recording the job, and then we are going to use the thermics, which are called as symbols, for writing the micro motions, identify the motions, remove the unnecessary movement involved again in that also, and make it more effective. Continuously the worker is doing the similar type of operation which are consuming it. Those are the repetitive type of operations wherein the worker is taking very less time, maybe 1 minute or even less than that. So such type of jobs are called as micro motion, or micro movements are involved in that. So how to improve, how to make it more effective, all those movements and all. So that you are going to learn in the fourth unit, the principles of motion economy you are using, and calculating the unnecessary movements, and you are using the charts. There for the method study you are using the outline process chart, flow process chart and all as the tools. Here you are using the SIMO chart, simultaneous motion operation chart, and you are going to develop the best method of doing the job, and you are going to install it, and you are going to maintain it. And you can say that if it is taking, say for example, 60 seconds, you can, if even if you reduce it by 1 second, it is more you can say that we have improved the productivity. Because such type of jobs in a day, they are continuously, they are doing it throughout the day. So even if you reduce it by 1 second, it will make a sense. Then fifth unit is introduction to work measurement. Once you have developed the best method of doing the job, then you are going to measure the work. So there again, you are going to learn what is the objective, what are the benefits, this, that and all. And few again techniques are there which you are going to learn to find out or to decide or to establish the time required to complete the job. That is, stopwatch time study is there, work sampling is there. These are the different techniques which we can use to establish the time of doing the job. So stopwatch, as the name indicates, you are going there, you are observing using the stopwatch, and you are writing it, and you are finding again after method study. Always you are doing first method study, and then you are going for work measurement. So this is what, so that we can understand how much time is required, and what are the allowances should be added to that, and what is the standard time, what is the normal time, what is the actual time. All those things you are going to learn, so that you can decide the wages for the workers, as well as the delivery date you can find out, so that you can to the customers you can tell that when you are going to deliver the product by calculating it. So for that we are using this work measurement technique. So this subject actually, this is very very important aspect nowadays. And so improvement of the productivity, in turn you are improving the profit of the organization in general. So you can apply it anywhere. So you can apply it to the business, you can apply it to the service industry, or you can apply it to the manufacturing industry, mechanical industry, or anything, anywhere you can apply it. And individually also, if you apply it, then you can improve the efficiency, your efficiency. So all these things you are going to learn in your that industrial engineering productivity management. So it's a theoretical subject. Very few, what you can say, the problems or numericals you will get. 10 to 20 marks numericals will be there. 80 marks it is a theory subject, and textbooks are already they have mentioned in your syllabus. If you go through the syllabus, you will find it all. Textbooks are available in our library. Even then we have lab also related to this. So we can conduct some experiments also, so that you can learn about the techniques. On job training also can be given nearby industries and all, and many of our students have done projects on these. Not necessary mechanical industry, mechanical students, anybody can take up this improvement technique. You can apply anywhere and you can use it. So it will be very very useful for all the students of any branch. And NPTEL and all those things have been given in the syllabus, that you can go through. Nothing else is remaining. So the skill, competence, and after undergoing this or after understanding this is analyzing the knowledge of analyzing the process, developing the best method, determining the standard time that you are going to learn. And industry, any type of industry, as I mentioned, health industry for example, you can say that hospitals or any type institution like GIT, anything, anywhere you can apply this, and you can improve the process, and you can improve the productivity of the organization. So that's all. So this is about industrial engineering and productivity management. Thank you.
Good afternoon, everyone. I'm going to talk about Open Elective course, which is Introduction to Astronomy. I'm Dr. Chetan Kudbagi from Department of Physics, and I'm also the coordinator for Center of Astrophysics. So before we go ahead, we'll just briefly look at what is astronomy. So it's a branch of physics that deals with celestial objects, space, and the physical universe. So why astronomy is important? Because it has played an important role in our lives. So if the movement of the celestial objects has brought us the concept of time or calendar. to our lives. So in that's how these concepts have emerged. So you can see that the Earth's rotation has brought the concept of day, then the motion of the moon has brought the concept of a month. And then the Earth's motion around the sun has brought the concept of seasons and the concept of year. And earlier, people used to study astronomy, where they used to look at the constellations and comets, and since they knew little about them, so the field of astrology was quite dominant in those days, which is a kind of a pseudoscience, which has nothing to do with astronomy. So now we call this field as multi-messenger astronomy. And why we call it multi-messenger? Because there are different ways to investigate the universe. Since we are looking at the objects which are very far from us, there are different means in which we can study these objects. The first mean is to look at what we call as electromagnetic radiation. So it's all the electromagnetic waves which runs from the radio waves to X-rays and gamma rays. So there are different detectors which are used to look at the universe in different domains and to learn about the celestial objects. So this is one way to investigate the universe. Second important method to learn about the universe is about cosmic rays. So these are high energy electrons, protons, or even heavy nuclei. They move at a speed which is close to that of light, and from that one can know about astronomical entities. Third one is about neutrinos. Those are kind of elementary particles which are produced in the fusion reaction, and the study of neutrinos can also give us a good insight into the physics that is going on in the celestial objects. Like one example is supernova, where a star explodes during the end stages of its life. So these can be studied using neutrinos. Then recently, like 6 years down, 6 years ago, we had a new kind of detector developed, which detected what we call as gravitational waves first time. So it's a kind of new telescope that has been found to look at the universe. And it looks, so gravitational waves are nothing but those are ripples in space-time. So we have a detector which detects these ripples, and using this detector one can investigate the collision. Like that's how the first time the gravitational waves were detected. They were detected during a collision of two black holes. So that's how one can look at the universe. Or the last one is where one can collect the samples. So we have meteorites or lunar samples. So these are different ways in which one can investigate the celestial objects. So now let's look at the course that we are going to do. So there are 5 units as usual, and in the first unit what we are going to do is we'll look at the basics of physics that are required to understand different astronomical phenomena. So it involves special theory of relativity, then it involves thermodynamics. It also involves some optics, because telescope is the one thing which is, or still it has been used widely to study the astronomical objects. So this review of the basic principles covers the required physics to understand astronomy. So those things we will be learning in the first unit. In the second unit, we will look at basically stars we are going to study, because see, stars make I mean, they are a major part of the visible universe, and what we want to look at is but the stars, they depending so the nearest star we have is the sun. So what we are going to do is we'll look at the sun, how the fusion reactions takes place inside the sun, how the heat, see, the fusion reaction inside the sun takes place at the core, but then the heat which is generated at the core, it gets transmitted to the outer regions, and then after the outermost layer of the sun, then it gets emitted into the space. So there are different processes that happen in this entire journey of energy which is generated at the core of the sun to the outer space. So we will look at this. So there are different layers of the sun which we observe. So we'll look at that, and we also look at the end state of a star, because now we understand that there is, like, star is born, it has a lifetime, and depending on its mass, it will have different ends, so to say. So it can end up as a white dwarf, it can end up as a neutron star or a pulsar, or it can end up as a black hole. So we'll look at these end states of stars in the second unit. In the third unit, we will look at more about the stars. So we have a range of different stars, okay, depending on the mass, they shine differently, and if the star is more massive, the way the life of the star goes is entirely different than a star which is like a sun. So sun is an average mass star. So we have a classification of these stars, and depending on this class, we see the evolution of the star happening. And depending on the mass, we also see these different end states of the stars. Then we'll also look at what we call as a binary star. So usually most of the stars in the universe, we find them in as twin stars. So two stars rotating around the center of mass, that kind of system. So we'll also look at that. So these two units basically focus on the stars. Then next unit we'll look at the galaxy, which is the larger structure that we observe in the universe. So galaxy not only includes about 100 billion stars, but more than that, it has interstellar medium like gas clouds, there are nebula, okay. So those make a galaxy, and galaxy, our solar system is in the galaxy which we call as a Milky Way. So we'll also look at some of the aspects of the Milky Way, but we also look at the structure of the galaxies. So like Milky Way is one galaxy, but there are many galaxies which have different structures. So we'll look at how the structure of the galaxies happen, and we'll also look at the magnetic fields that are produced in these galaxies, how the magnetic field influences the motion of the cosmic rays in this. The last unit we will look at is more of the study of cosmos. That's what cosmology stands for. So now we have different concepts like Newtonian mechanics. One can use Newtonian mechanics to study the cosmos, or one can use Einstein's general theory of relativity to study the cosmos. So there are different cosmological models which have been proposed to study the cosmos. So we'll look at those different models, and we'll also look at the Big Bang theory, which is now widely accepted theory for the origin of the universe, which tells us that the universe began at a very energetic explosion which took place around 13 million years ago. So we'll look at the Big Bang theory and also its component theory, which is now not so. Since Big Bang we have experimental proof, the steady state theory is no longer accepted as the valid theory of the universe. But nevertheless, we'll look at the assumptions at those in this theory. So if you see this, the journey we do in this course is we start with the stars, then we go to the larger structure and the contents of it, and then we look at the most large structure that we have is the cosmos. So this is what we are going to do in this course, and the physical universe by Frank Shu will be used in this course. The course, to be precise, the course will have application oriented course. Means you know formula for Newton's law of gravitation, so you will apply that, let's to say the mass of the sun. So so it involves simple physics, but it is more of a kind of application oriented course, so you can understand better the physics behind these stellar objects. So what are the things you can have after doing the course? So if you do this course, the institutes like Indian Institute of Astrophysics or National Center for Radio Astronomy, they need engineers to build, let's say, a radio telescope, or even for optical telescope, you need mechanical engineering to build very large optical telescopes. So that kind of opportunities are there. One can also do research if you are interested more in astronomy at national level institutes or even in the universities abroad. There are also job openings in the outreach program. If you are interested in outreach activities in astronomy, those can be also available. And the last thing is for software engineers. Like now, a lot of things are done in this field because of large number of data. There are many surveys that have been conducted, so there is large number of data which needs to be studied. So there are also many opportunities available in this field. So that's all from my side. Thank you.